All right, let's dive in. Today, we're talking about a really cool tool designed to solve one of the biggest headaches in engineering. How do you get crucial answers right at the start of a project? You know, when you need them the most. If you're a designer or an engineer, these questions are your life, right? You're staring at a blank slate, a new concept, and you've got to ask, is this thing even going to work? And these aren't small details. They are the big make or break questions that decide if a project gets off the ground. And that brings us right to the heart of the matter, the early design dilemma. We're talking phase 0, phase 1. It's this constant tug of war between needing to move fast, to brainstorm and try out new ideas, and needing to be accurate, to know if those ideas have any chance of surviving in the real world. Here's the problem. Our best tools for accuracy, I'm talking about things like detailed finite element analysis, or FEA, they're like supercomputers. They are incredibly powerful, for sure, but man, are they slow. You just can't run a full-blown simulation for every little tweak you want to try. It creates this massive bottleneck right when you need to be creative and move quickly. And this is exactly where the HSF Material Stability and Failure tool comes into the picture. It was literally built to solve this exact problem by giving you a super fast, analytical way to get engineering insights pretty much instantly.
So what is it in a nutshell? Well, think of it as a quick and dirty, but really smart analytical tool for checking out the most common structural issues. We're talking bending, twisting, fatigue, all for basic shapes. It's kind of like your first line of defense in the design process. And I love this slide because it just nails the concept. If FEA is your supercomputer that you bring out for the final heavy-duty validation, then the HSF tool is like the powerful engineering calculator on your desk. You use it for those quick checks, the what-if scenarios. It gives you that gut check that you're heading in the right direction. So let's get into the nitty-gritty. What can this thing actually tell you? This is where you'll really see its power for that early design phase.
First off, it handles the basics of structural response. It'll instantly tell you a part's natural frequency, which is absolutely critical if you want to avoid your part shaking itself to pieces. It'll calculate your stresses from bending and twisting, and then, and this is key, it rolls them up into the von Mises stress, which gives you one clear number to see if you're getting close to failure. Okay, now let's talk fatigue, because it's not always about surviving one big hit. It's about surviving millions of tiny ones. This tool uses the same industry standard models professionals use to estimate fatigue life. And it's smart, too. It accounts for things like mean stress, stress concentrations from sharp corners, and even the surface finish. All that good stuff is baked right in.
And finally, stability. Is the part going to expand so much from heat that it breaks? If it's a long, skinny beam, is it going to buckle like a soda can when you push on it? These are the kinds of catastrophic failures you have to catch early, and this tool gives you those go, no-go answers in a flash for simple beams and plates.
All right, so those are the features. But how does this actually change your day-to-day work? Let's walk through a few real-world scenarios. This, right here, is the magic. You can just ask questions. What if I make this wall 2 millimeters thicker? Change the number. Boom, you get an answer. What happens if I switch from steel to aluminum? Change the material. Boom, new answer. You're iterating in seconds, not hours. This lets you explore dozens of options and zero in on a much better design way, way faster. For the pros out there, this tool is also an incredible sanity check. Let's say you just got a big, complex FEA analysis back. Do the numbers even make sense? Are the stresses in the ballpark of what you'd expect? A quick check here can give you confidence that your big model is on track, or it can wave a big red flag that something's wrong before you waste any more time. And a material trade study like this is a perfect example. I mean, look at this. In just a few seconds, you can see the whole picture. Aluminum gives you a great stiffness to mass ratio, but whoa, look at that fatigue life compared to steel. And then there's titanium with its off-the-charts fatigue performance. This isn't just guesswork. You're making data-driven decisions on the fly. Okay, now for something that's just as important as knowing what the tool can do, and that's knowing what it can't do. Understanding its limits is absolutely critical. Let's be crystal clear about this. This is an analytical tool. It is for early-stage design. It is not, and was never meant to be, a replacement for a full-blown finite element analysis or the rigorous process of getting a part certified. This side-by-side really spells it out. You use this tool for quick checks on simple shapes, for getting first-order answers, for doing trade studies. The moment you get into complex curves, weird geometries, or need to analyze advanced stuff like weld fatigue, that's FEA territory.
And if you need any kind of official approval, FAA, FDA, you name it, you're gonna need validated FEA or physical tests, no question. So who is this for? Well, it's perfect for mechanical and aerospace engineers working on new concepts. It's an amazing learning tool for students, and really anyone designing drones, robots, or any new product that needs fast, reliable structural feedback will find this super useful. At the end of the day, it really all comes down to this one simple, powerful idea. The whole point is speed. But giving you instant feedback, it just radically accelerates that early design loop, which lets you find and develop good ideas faster, and just as importantly, lets you figure out which ideas are bad and fail fast. And so I'll just leave you with this final thought to chew on. What kind of new things could you create? What possibilities open up when that barrier between having an idea and testing it shrinks from hours down to just a few seconds? What could you build?